Hello and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. We're moving on to a new chapter now, and this chapter we're going to learn about abstraction and polymorphism. Most of our time will be spent on polymorphism. These two topics are related in many ways, and in many ways the concept of abstraction is something that is going to span through the entire rest of the second half of this book. It's probably one of the most important things that you will learn in computer science. And the idea here is that when you solve a problem, you shouldn't actually just solve one problem. It would be much better to solve an entire class of problems. Ideally, you could write one solution and solve an infinite class, an infinitely large class of problems. That's one of the goals that we have with our programming. And part of this just goes back to the don't duplicate code. If you can write code once and have it solve an infinite number of problems, as long as some of those other problems are things that you need to do eventually, you'll save yourself a lot of effort in the long run. And so we want to start looking at how you can do that, how you can add abstraction to your programs, how you can think more abstractly as opposed to writing things that are very concrete and it solves exactly one problem, how to abstract things out so that you gain more flexibility. And one of the major tools we're going to use for this is polymorphism. Now, polymorphism, and if you go to the Greek roots, literally means many shapes. And in programming, we're not talking about shapes. What we care about is types. And so code that is polymorphic is code that works with multiple types. There are many types of polymorphism. If you only work with a few different types, that's referred to as ad hoc polymorphism. There are also types of polymorphism that allow you to work with an infinite number of types, going back to the idea that we want to make it so that our one solution can solve an infinite number of problems. And so these are referred to as universal polymorphism. Now, you might ask, how can you actually work with an infinite number of types? You can't write an infinite number of types. But if you look at this from the mathematical perspective, the idea is that it will work for a certain number of types, and you can always add one more. So you could always create another type that it would work with. And so by that definition, it's an unbounded number of types, effectively an infinite number of types that you can work with. And so in this chapter, we're going to talk about two different forms of universal polymorphism. We're going to talk about inclusion polymorphism and parametric polymorphism. In this video, I want to kind of introduce you to some of the ideas behind how we're going to make this happen. We've actually seen a little bit of this. If you go back quite a ways in the book, we had some code where we wrote functions and we made it so that the functions could be passed in, so when you called the function you could pass in other functions, or you could make it work with multiple types. That's the idea that we really want to play with in with the polymorphism. And just for this video, I want to show you some places where this pops up in the Scala API. Okay, and I can show you examples both that use inclusion polymorphism as well as examples that use the parametric polymorphism. And so I'll start with, actually, while we will cover inclusion polymorphism before the parametric polymorphism, I'm going to start with examples going in the opposite way. And so imagine, let's go into our collections library, and let's pick the first type of collections we ever talked about, sequences. Okay. Sequence, this bracket notation here, which of course at this point is you're very familiar with, this is what indicates parametric polymorphism. It means that the sequence can work with lots and lots of types. How many types? Well, an infinite number of types, in the sense that you can always create another type that it will work with. And so that means that inherently our sequence is polymorphic, at least the one that's in the library. And we haven't really learned how to write those yet, but we will by the end of this chapter. And you can come into here and some of our fun higher order methods. So let's go to map. Map is probably one of the best examples of a good polymorphic function. And remember, what happens when you call map is you pass it a function, and that function is supposed to take the type A that this is a sequence of and then give you back some other type, and it returns a sequence of that type. And so this is a higher order function that can work with many different types. And it's not just that it can work with a bunch of different types A, it can work with a bunch of different types B and all different combinations of the two. So this is very highly flexible, and you've been able to see that in your coding so far. And you might not have thought about it, but you have used map for doing many things. And a big part of what made map so flexible was the fact that the types of the things that it worked on could change. And you could, you didn't have to, the libraries didn't have to create a separate version of map for every different type. So maybe you wanted to map from ints to strings. They didn't need a separate version of map for doing ints to doubles or ints to booleans or whatnot. All of those were using the same map function. And so that's one example of the power here. The example that uses inclusion polymorphism, and inclusion polymorphism is basically subtyping. And for that, I think the example that will stand out to you most is here inside of the GUI libraries. So inside of Scala Swing, think back to the panels that you had. So I could pick, let's go ahead and let's pick a border panel. Actually, okay, well, how about we pick a grid panel? The border panel has a layout. Grid panel is a little bit simpler in that you have contents. And so your contents is a buffer of components. Basically, it's a sequence of these components. And so what can you put in there? Well, and when we wrote these things, we put buttons in there as well as list views, and we put basically all of these different types of things, or at least a large number of them, could be set as as the contents of here. That only worked because the code was polymorphic. Buttons and list views are very different. They have very different code, they have very different functionality, they don't really look anything alike. However, we were able to stick both of them inside of a border panel, right next to each other. Why? Well, it turns out that both the button type and the list view type are subtypes of this thing called a component. And so in our next video, we're going to look at how we create that in the code, how we create subtype relationships, and then start to incorporate some of that into our own coding. So that's it for this video, and we'll come back and we'll actually do some of the inclusion polymorphism and show you how you can start writing classes and functions and methods that can deal with literally an infinite number of types as long as you play your cards right.